helping in a big way, super big thanks. And as well as SEMA. And speaking of SEMA, March 7th, we're gonna have an amazing event with a ton of students, and they're gonna be bringing their cars. We're gonna be inspecting their cars for both Baja and Formula SAE. So if you're interested in volunteering to put on events like these, or come out to that event and help critique some of the students' presentations or designs, come see me afterwards. And a big shout out to the Lions Automobilia Museum for hosting us here tonight. And also for the first time, the Lions Club doing a little bit of grilling with the hot dogs. So thanks to all of them. And so with that, I want to welcome our first speaker, Mike Spagnola, the CEO of SEMA and PRI, to tell us a little bit about SEMA and how it relates to SAE and the OEMs.
I can still get up like that. That's pretty good, old guy. Hey, thank you guys all for allowing me to be here tonight. Is this place not like the hidden gem of Southern California? I mean, it's just incredible. Lana, where's Lana? Lana, you're not here somewhere. Okay, I'm gonna call you out, you're not here. But what a hidden great place to be. So, hey, listen, it's a pleasure to be here, and it's a pleasure to represent SEMA here tonight. It's right here in our home tour, so it's exciting. Our headquarters is just a few miles up the way in Diamond Bar, here in Southern California. So, we're not just visitors here, we're neighbors. And so fun that's had a chance to talk to so many of you guys tonight, to be here, and what a great place. I've spent my entire life here in the industry, and here in Southern California. I started in high school as an auto shop guy, and really didn't know what I was going to do in this industry. I just knew I loved cars, and took auto shop as a junior in high school. Went on to vocational auto shop which was a 2-year class my senior year. And a guy came in that was a SEMA member that had gone to my high school and said, I'm going to give a $200 automotive scholarship to the guy who does the best in class. And I wasn't a sports guy. I wasn't, the high school quarterback most popular into that kind of thing, but I was pretty good in auto shop, and I won that scholarship. And the guy that gave it to me was Mickey Thompson. So that was my start. Anyway, it's been an amazing career. I've spent, again, my whole life in this industry, but I'm a gearhead first. I still like to work on cars, although I just had to talk to somebody about finishing a car for me, because this job keeps me pretty busy, but it's been really fun. And I know everybody in this room talks about spark, but it's spark and it's passion that really drives our industry. And if you love this industry, you need to be part of it. If you love cars, you guys need to be part of it. You guys students, I see so many students here. You really need to be part of it. And what we do is we take cool cars and make them faster and better and cooler and all those sort of accessories. So I'm a huge fan of Formula SAE and the Baja SAE. It's an incredible program. We embrace it pretty hard at SEMA and PRI. We do a job fair in March in our SEMA garage here in Diamond Bar. And I think we get about 400 students. We bring in industry people, and we bring in students, and we have some cars there, and it's a really fun day. We also do it in our SEMA garage in Detroit with about 120, 130 students. But we really talk about careers in the automotive industry. And my speech to all you guys that are students is, we're obviously, I wish I was an engineer. I'm not, but we need engineers in our field. And what I love to tell students is that, look, you can graduate from college and you can go to work for Boeing and you can work on a hinge for 2 years, or you can come to work for a SEMA manufacturer and you could be working on a supercharger for the 26 Corvette the next year. And so it really gives you an opportunity in our industry to go to work and to be part of our industry and be part of it. And we need engineers. Luis Morales is right here. Luis, say hello. Luis is one of our engineers. I think every one of our engineers in our SEMA garages came from the SAE program. And I was talking to Kurt. Where's Kurt Miller? I saw Kurt a second ago. Kurt? There you are, Kurt. Kurt was telling me today, he was at my shop, my office today, and I think he said over 20 of his engineers came out of the Formula SAE program. So it's really important to us. And I don't know how you got Tommy Kendall here tonight, but I'm a big fan of Tommy's, and quick story, Tommy, you don't know this, But I thought I was going to be a race car driver. That was really what I wanted to do. And Tommy and I went out one night, and I thought I had a lot of talent until I raced Tommy. We went out and did go-karts. And I was like, it's time for me to hang this up and try to make a living in some other way. So, Tommy, I've never told you that story, but I've told it to several other people. Anyway, listen, this is an incredible program. We're big fans of it. We're big fans of obviously the aftermarket. Dean Case, who you guys all know, everybody knows Dean. Dean was our Person of the Year this year. I mean, that's how much we embrace. He was our SEMA Person of the Year out of 7,000 members and 160,000 people that come to the SEMA show. I was excited that we honored Dean Case as our Person of the Year. So that tells you, I hope, how important this industry is for us. So, listen again to you students, education is really important, but it's dirt under the fingernails that's going to get you guys the experience you need to move forward. And the other thing I want to tell you guys is that to you students, I've met a lot of smart people in the world in my now over 50 years in this industry. I haven't met a lot of people that want to work hard. And if you want to be successful in this industry, you're going to need both. And so I hope that you would come to work for us and be part of our industry and be part of the whole thing. So about a year and a half ago, an article came out that said that SEMA has become the center of the automotive universe. And it really kind of sparked me to say, you know, how do we get there? What do we do? But to give you an idea, we represent over 7,000 companies across the United States, and we're a $337 billion a year economic impact in the industry. We employ 1.2 million American jobs. So, you know, that's a reach that is pretty important to us. And we do a lot of work in government advocacy to make sure that we can continue to modify vehicles and be part of it and all that. But what's really going to come into play now in the next few years, and again, here's where we really need engineers. Of course, we've always built high-performance parts, and we've always built all those sorts of things, and now ADAS is coming into play, and that's a game changer for us. So it's all the advanced driving assistance programs, and Luis is heading up our program in that right now. But think about this. With all the cameras and all the braking systems, all the lane change departure warning systems, and all that that's coming into cars, 2029, automatic braking becomes mandatory. And we're working with NHTSA right now on what those rules are going to look like. But think about trying to lift a truck or lower a car or put a different set of tires on it and what that does to stopping distance. And when you lift a truck, what do the cameras see, right? Because now you've changed the angle of what those cameras see. So we're working really hard right now to get ahead of all that, and we're going to need engineers, both EE and ME engineers, to really understand what happens and how that happens and how we can modify or get into the CAN bus to modify those cameras so that they can see the right things. Because now you're talking about life of limb products, now you're talking about safety issues. And to give you an idea, there's about 800 SEMA manufacturers that affects. So there are 800 jobs right now that people are looking for in the EE and ME business that's going to affect our future and our ability to modify vehicles coming really soon. And so there's just tremendous opportunity out there for those sorts of things. The other thing that we're pretty involved in is just government affairs, and we're pretty active politically in a lot of areas to continue to make sure that we can modify vehicles and modify them safely. ADAS is part of that. You guys may know that last year or earlier this year that Trump signed the EV mandate rule that said that EVs are no longer mandatory, that you should be able to choose the vehicle you want to drive. And we're not against EV, but you should be able to choose what you want to drive. That was our bill. And I was excited to be able to go to the White House for the signing of that bill. But it was something that we thought was really important to be able to continue as a country to pick the kind of the vehicles we want to choose to drive. And so those are the sort of areas we get involved in politically. There's a lot more issues right now. We're working on a right to modify bill right now. We're working on bills to save racetracks across America because we're seeing some of our racetracks go away. We don't have racetracks. We don't have products to build, and those 102 million jobs go away. And so I think I got a D in civics in high school, to be honest, and somehow I got thrown into some of this government affairs stuff, but it's been really fun and it's been really exciting, and we're part of that. The other thing that you should know is there's a lot of SEMA and SAE overlap, and it's a bridge between the OEs and garage. We work closely with Ford and GM, Chrysler, just every OE out there on these things like this ADOS program. We also do this, what we call a tech transfer program, which is CAD data that we supply to our manufacturers that the OEs give us. Jim Moore is here as well. Jim runs our garages in the back, so thanks for being here, Jim. We do that ADOS testing. We're doing dynamic testing and static testing. What that means on ADOS, you guys have seen probably the cars that run down the test track, and then a balloon person or a balloon car steps out front of them, and the car's got to stop within a certain amount of feet. We're doing that testing now on modified vehicles. They're about $100,000 a test, to give you an idea of what these things cost. So, but we have to do that kind of work. So we have to get ahead of it, or we're not going to be able to modify vehicles. So we want to meet the same standards as all you guys do in SAE, and we want to develop standards going into the future. We're doing that through SEMA certified and those sorts of things. So we need your brains, students. We need your brains. We need your hard work, and we need your passion. Guys like me are going to fade out here in the next few years, and we need the next generation in to carry that torch for us. And it's that torch, as you look around, this garage has been around for many, many years, since the 40s, really, when we started modifying vehicles, but it's never been more exciting. I hope you guys know about the SEMA show, but we do this thing called the SEMA show every year in Las Vegas. And that's what we do 4 days of the year. The other 360 days a year, we're doing these other things. But SEMA show is a pretty amazing event, and I hope some of you can make it out next year. We'll certainly make sure if you students want to come out, we'll get you some passes. But it's an exciting time. We get about 1,500 vehicles. We light up a few tires, and we buy and sell a lot of parts. And it's just, if you have any passion to be in this industry, you need to be in a SEMA member company. You need to be developing parts and be the next piece of fabric part of our industry. So thank you very much, everybody, for being here tonight. And I think I'm turning it back over, yeah, if you don't mind. Thank you, guys. And thank you. Tommy, I might take you back on the co-car track these days. We're both getting a little older, so I might put you on the wall too.
Oh, well, thanks so much, Mike. I mean, I think SEMA, you guys do so much for our students, and for doing what you're talking about. I think every March when you host that event, 50 students get placed at a job there. And I could say the same. I mean, so these next 5 folks that are going to come up for the panel, I think they're all not also just very dedicated and passionate engineers. The other thing that I think is just amazing when I look at these 5 people is they are just very dedicated to helping students. I mean, I've been on calls with Ian at 1 o'clock in the morning East Coast time when he's trying to meet with us out here. Damon's out doing Formula SAE EV inspections for 12 hours a day in Michigan. Same with Kelly, Louise, Michael's been a volunteer speaker for as long as I can remember. So anyway, so with my great pleasure, I'm going to welcome Michael, who's going to moderate the panel and our 5 speakers up. And I just want to say thanks for all you're doing for students and, for the automotive industry in the area. Hopefully we can also learn what hard tech is today. I'm excited about that.
We're just making up words. No, that's, we talked about that after SEMA. You guys need water? You get it? All right. Thanks everybody for coming tonight. I guess first of all, thanks Lions Museum for hosting us for sure. Obviously SEMA and SAE coming together is really powerful. Like everything Mike said is like right on the nose on the impact we can make in the industries. I always do a little bit of like, it's not just for the engineers and technicians too. As you can tell by Ian and I's shoes, one of us makes parts and one of us makes spreadsheets. But very similar backgrounds. I actually came to Motivo because I invited Dean to come out and talk to my Formula SAE student 8 years ago, and weaseled into an interview at Motivo and came in as a project manager and ended up as the chief business officer. And so like the path still follows similar things, even if the destination's not the same for everybody. So I think one of the great things for me and why I always am trying to be as supportive possible, the students through SAE and SEMA, is everybody has a different journey as they go through it, and there's a great support system to follow those journeys. And so I try to stay involved in any of the SAE chapters. When I lived in LA, somehow I ended up in Detroit, and then that changed nothing because I just got roped into SEMA Garage out there, which I've been loving, and then getting pulled back to California regular basis to do talks like this. So again, support both organizations equally. They're there to support you and really take advantage of the resources provided through them. And one of those resources is going to be access to people like I have here up on the panel. So we did a talk similar to this at SEMA a couple months ago. And really the idea came through a conversation about, we see the progress of software development and everything has branding of artificial intelligence over the top of it. And everybody is assuming that the speed of development is kind of happening at the speed of that marketing and that software development. And right now, a lot of people are losing sight about how hard it actually is to develop hardware, physical things that we all touch and use on a daily basis. So when you think about hardware technology, hard tech, that's what we're talking about. And so the idea was to kind of bring this group together to talk about their experience in developing and designing and implementing and producing hardware, things that actually make it out in the world to be touched, and what the challenges of doing so are and how you kind of overcome them. And so the idea is kind of talking through how do we get over the hurdles of developing in hard tech. So great panelists. I'm going to let each of them kind of introduce themselves and talk a little bit about where they work and what they do, and then we'll jump into some questions.
Thank you. All right, my name is Ian Lehn. I started and founded the company when I was a Formula SAE student at Georgia Tech, BOOSTane. We make race fuels and fuel additives. And then I have another company where we manufacture truck accessory parts and kind of the next evolution of Molly panels called Mobile, and get to play with hard parts and all that good stuff. But yeah, the whole thing kind of started in the Formula SAE lab. And I made race fuel, and I kind of developed BOOSTane out of a function of not being able to afford race fuel when my buddies and I wanted to go racing on the weekends. So we basically used that lab to make my company, and went to SEMA and won Launchpad. And next thing you know, I'm getting voluntold by Dean Case to fly across the country from Ohio to be on a panel, but it's freezing there, so I'm happy to do it.
Hi, everybody. I'm Kelly Olischefski. I'm a business operations professional, and I have degrees in mechanical engineering and in business. And I have enjoyed a career in new product development for over 30 years in the automotive industry, in performance racing, and then I transitioned into running a precision manufacturing company. So I went on to the flip side and had to manufacture parts that engineers were designing. So I in a unique situation where I get to see these things from both angles. And that's me in a nutshell. Thank you.
Hey, Damon Pipenberg. I'm the CTO at Motivo, so also work with Michael every day. I've been there 15 years, started there when it was 5 people, I think. That's where I met Dean initially. But no, I got my career started in Formula SAE as well at Georgia Tech. Did that all 4 years. Amazing experience for me. Really jump-started it. Helped me figure out what I wanted to do with my life. Probably one of the few people in Formula SAE that did not meet Dean through that program, but happy to know him now. So yeah, at Motivo, I've always been in engineering. We do kind of product development in automotive and aerospace, nowadays robotics and automation, and really do the whole thing from taking people's ideas to making prototypes, testing them, to manufacturing them in small quantities. So super exciting, and yeah, excited to get to talk to you all today.
Hello. Hi, Luis Morales here. I'm with SEMA. Actually, I've been with SEMA for nearly 10 years, actually coming up on my 10-year anniversary this year. Mike Spagnola himself hired me straight out of college. I went to Cal Poly Pomona. I got a mechanical engineering degree there, and I was also part of the Formula SAE team. So with that history, he believed in me, and I was hired on as a mechanical engineer within our department. And fast forward 9 years later, I oversee that part of the department now and some other fun stuff that I'll talk about later today. But yeah, there's a lot of really good opportunity in networking with a lot of folks within the industry. Like Mike said, there's a lot of opportunity in the aftermarket. It's very, very rapid pace, I would say, in regards to comparing it to like an OEM, for example. So, I mean, you're talking about getting access to a vehicle today. You better have a prototype in, less than 90 days, ready to go to market with tooling, within 6 months. So it's very rapid pace, high risk, high reward as well. So it's very fun. So I get a chance to work with a lot of our members, connecting them with students, connecting with other folks within the industry like OEMs, learning about new technology, staying on top of vehicle technology, such as the ADAS stuff that Mike talked about, which we'll get into later. But yeah, pleasure to be here with you, and looking forward to the discussion.
No, thanks everybody, appreciate it. I guess as an official introduction, so Michael Konig, Chief Business Officer at Motivo. So I work with Damon every day. Been at Motivo for 8 years, do have an automotive engineering degree, never used it once, went straight to project management side. And now just do kind of the day-to-day operations of keeping Motivo running and pointing in the right direction so that our engineers and our technicians can work on all the cool projects that come through. So that's kind of my focus. So thanks everybody for joining us today. But yeah, we often hear that hardware-based development is complicated, expensive, and risky. And that's because hardware can be hard. And so as you go through and develop something that's going to actually touch, actual people or out in the world or be, influenced by the elements around you, you have to take all those things into consideration. And so when we talk about some of the design cycles and changes, they often become more compounded. As you change one thing, it interacts with another thing, so you have to change that. You got to look at the entire system as it rolls up when you're doing hardware-based interactions and subsystems working together. And so a lot of it is looking on to people who have gone through it, understanding their expertise, how they've overcome some of those challenges, and really understanding what that is to keep in mind for when you're developing your programs, whether that's all the way down to a Formula SAE car, all the way down to building up your Legos as a kid, and then all the way up to having a full career making parts, whether that's aftermarket car parts, full-blown buildings, airplanes, really anything that's going to be physical out in the world. So I guess kind of throwing it to the panel. So each of you have worked in kind of different corners of hard tech, from advanced engineering, supporting automotive aftermarket, and all the way through manufacturing. Can each of you kind of think of a project that really challenged you on developing on physical things and what you did to kind of overcome that challenge?
Trying to remember kind of what I said at SEMA. The Forged Authority off-grid, we manufacture truck panel accessories, kind of quick attachment stuff for off-road racing to kind of the trades. And the challenge that I think our team I'd say that we adopted something early that I was very happy about, and it was that we took it out of the virtual space as kind of quickly as possible. And what we realized is it's just better sometimes to prototype as quickly as you can and see where things are going to break. I think sometimes it's easy to get hung up in the virtual space because we have so many tools that are accessible to us now to do FEA but at the end of the day, sometimes you just got to bolt the thing on and let it rip. And we've always been able to kind of overcome some of the kind of the stopping points that we find ourselves on by just putting it on there and going out there and testing it and breaking it early and kind of failing fast and getting right back to the drawing board.
I've had a couple of situations where I had to rethink my approach to things, and both stem from I started out in the automotive industry, which was really high volume. Well, everybody has a different perception of what high volume is. For me, it was 11,000 parts a day is what we were making. So pennies mattered, and seriously, some people think that's low volume. Depends who you talk to. So we were making 11,000 a day, and every penny mattered, and everything that you did was just microanalyzed, and there was tooling budgets, and you had to, one of the things you do is you get creative in your tooling, and you plan ahead. Well, how many varieties are we going to have of this product, and you allow for that in your tooling, and you put inserts in your tooling and things like that. You do all this planning up front. And then I transitioned to performance racing, which is low volume. Sometimes we'll make less than 10 a week. And that was a huge transition for me. And just the volume changed. Now we're doing a lot of machined parts and having trouble finding vendors who will even work with us. But what was more interesting was the cost didn't matter. The weight did. They were willing, racers are willing to pay a lot of money, a premium this was for data acquisition systems, for something that's lighter than the competitor. So that was a big shift in mindset for me that I transitioned to it.
Yeah, I think for me, like I said, I started at Formula SAE and really learned the process of iterating, like design something, go build it, and go test it. And I think where I've seen that go wrong on projects at Motivo is if you skip any one of those or don't go through them at the right speed. And think of an aerospace project where we spend a huge amount of money building and testing something just to realize that like the very basic mechanical engineering at the beginning, like the hand calculations, kinematics are wrong. And we can test it all we want. It was never, ever going to work. We just wasted a ton of money on it. Other ones where you sit on the computer for weeks and weeks and weeks designing something and get to build it and realize all the engineering was wrong because you should have gotten to testing it quicker. So that's, I think, always a balance. Figure out, get your engineering fundamentals right, but then also go build and test stuff and iterate quickly. This is no real alternative to putting something out there and testing it.
Yeah, we host these events known as measuring sessions within our SEMA garage facilities. That's when we collaborate with vehicle manufacturers to bring in either pre-production vehicles or new release vehicles into our facilities and invite hundreds of aftermarket companies to come and see them for the first time. In many cases, get a chance to get their hands on it, develop prototypes, and essentially develop aftermarket products in a very short window. So you have to think about putting yourself in the position of not just you, but then you're around your competitors and other folks within the industry around this vehicle at one given time. So you can imagine that builds a lot of pressure on you. And then you got to think about, okay, how do I develop my product for this vehicle based on whatever previous generation, or maybe it's a brand new platform overall. So that builds a lot of pressure on the aftermarket designer and prototyper there. And then you got to go back to your engineering team and develop that initial prototype. And going back to one of the points that Ian made, you can't skip like the fitment part onto the vehicle. Like that is critical. So you have to go from design to prototype. You better test fit that prototype to assure that tooling fits onto that part before your member or your customer installs it. So we see a lot of that in the aftermarket. And like I mentioned earlier, it's speed to market. So you got to get to market as fast as possible if you're going to be competitive and try to be profitable. But you also have to do that very responsibly.
So you can tell some of us have done this talk before because perfect segue. So let's talk about prototyping and hardware. So we often hear that prototyping with hardware where you're going to consume physical goods is slow, expensive, time consuming, especially when resources or time are tight or even budget is tight. And so as you go through that process, any insight on how you say this is good enough on the prototype level so you can start testing?
Well, was it General Patton that said like a good plan executed today is better than a perfect one tomorrow? With all the resources that we have that are able to get us to a more rapid prototype from 3D printing, any of those types of opportunities. I mean, probably say good enough too quickly sometimes. But I mean, yeah, like what Luis said, I mean, with Fitman, it's like, sometimes you got to see if your finger will fit behind the thing to tighten the bolt, and I think we've all probably had busted knuckles in this room. And it kind of comes down to a little bit of the user experience with some of the hard parts that you're making, because you can make something that, functionally, meets whatever the requirement is, but if it doesn't have the form to meet that function, and the customer kind of is frustrated halfway through it, you're going to have a lot of, pretty bad phone calls down the way. But yeah, I mean, the good enough aspect with obviously price and things like that. And there's some stuff that you can't make out of PLA, but there sure is a lot of stuff that you can, especially when you're kind of on a bootstrapping budget. I mean, SEMA is made up of companies that are built around bootstrapping. So, don't be afraid of just putting it out there.
My approach to prototyping, comes from a heavy R&D focus, and I would always encourage people to keep it simple and break it down. Like if you're looking at new technology, only prototype that aspect that you're trying to prove out and test. So just break it down. You don't have to prototype the entire design and assembly. Just test one aspect of it at a time, and that helps keep your costs down.
Yeah, I think I would agree. That would be one of my biggest recommendations. Know exactly what you want to test, keep it simple, and go do that as quickly as possible. I don't think about, like in our shop right now, there's a giant project going on, and they're prototyping stuff out of plywood and cardboard. And you can learn a ton from that if what you want to learn is like, what is this space going to look like? So yeah, try to think what you're going to test and how to get to that quickly. Because prototyping is expensive, and it takes time. So try to do it efficiently.
Yeah, in the aftermarket, when you develop a product, say, just pick the 2026 Toyota Tacoma, right? You develop an aftermarket front bumper for this vehicle. As Mike talked about in the intro, there's all these driver assist systems that are on board of these vehicles nowadays, and a lot of those are driven by ultrasonic sensors, radar, camera, LiDAR. So when you develop your prototype and you test fit it on one trim level, that part may not carry over to the second or third other trim level option out there, because the higher level trim levels may be equipped with the sensor technology behind that bumper that you did not develop your prototype for. So when you select the vehicle that you're going to test fit your prototype onto, you have to have a clear understanding of the overall fitment application there, especially as we get into the higher level technology vehicles like what you see today.
You guys are making such good segues. I'm loving this. So I think that's a great way to summarize like how it's good enough on the prototype level to get tested. But oftentimes in your testing, those prototypes are vulnerable to environmental impacts or other physical things that could actually deteriorate it or reduce your durability. How do you kind of account for some of those factors if you know the final product is going to be exposed to those, but you want to get testing as quickly as possible?
I don't know about the quickly as possible part, but I come from the automotive industry, and it's very rigorous in their product development requirements. And we use something called the DVPNR, and it's design verification process and report. And it's just a very, that's how we did it. It's a very rigorous process. It comes from your design FMEA, and you just list what are you going to test, what type of prototype you're going to use, and what are the results, and the type of tests that you do come from your design FMEA, like what are the failure modes you're anticipating and what do you want to test for. That also comes from your regulatory requirements, whatever certifications that you're trying to get your product certified for, and so that's what we did. It was just a really rigorous fashion, and I've used that my entire career because I found it proactive and prevented a lot of headaches later on.
can jump in. So I've, what we see today in the aftermarket, at least from the manufacturers that I deal with, is a lot of them are gaining experience in becoming tier 1 or tier 2 suppliers to vehicle manufacturers. So when you take that step as an independent aftermarket company to say, I'm going to be a supplier to the OEM, you have to really go through this large learning curve of, there are certain FMVSS or DOT requirements you have to face. There's durability tests that you have to go through. So a lot of our members get exposed to that, and thereby, because of that exposure that they get, they take that back to their traditional aftermarket companies that are not necessarily tier related, and they'll apply those practices to them. And then their competitors see the application. And a lot of it goes with marketing, right? You test that your vehicle is compliant to this safety standard, and your competitors are going to want to chase the same thing. So what I've seen, at least in my time in the aftermarket, is I've seen this evolution of aftermarket products getting more and more durable, if you will, because they're considering the materials and the exposure that they're getting. So I would say an improvement, and a continuous improvement.
I can add a little bit of a story to this one as well, that are probably relevant to some of the formula students. So I went to college in Washington State, did Formula SAE. What does Washington State have a lot of? Rain. So all of our test days were actually done in the rain. And so our car was designed to a certain IP rating, so our ECU wouldn't shut itself down if it got wet. So when we went to competition in Omaha, Nebraska, and a rainstorm came out of nowhere, even in the middle of June, you could tell the teams that were from Southern California, Arizona, Texas, because all their cars stopped running. And so it was about, we got to test in an environment that we had to build durability for, and we just got lucky enough, I guess, that environment presented itself at competition. So it was a really interesting thing to also then carry back to the team for following years. And now when I talk to teams in Southern California, one of the first questions I ask during test season is, have you tested in the rain yet? And they're like, no, it doesn't rain here this time of year. It's like, you should call your local fire department. They'd be more than happy to soak your car and let you drive around in a parking lot, I promise. Look for those opportunities, because you can't predict what your test environment is, especially in Formula SAE. And so as much as you can hedge your bet to what the possibilities are and design around those constraints, even at the prototype level or the Formula SAE level, it makes you more competitive, it makes you more viable in that competition.
There's also, I've found a lot of success leaning on the peers around me. We're just at Media Trade Conference in Anaheim this week, and a lot of influencers and other people out there. Oftentimes when I got to do testing, I'll call Luis and ask him or reach out to Motivo, because we're not 11,000 parts a day. I'd like to get there someday, but I lean a lot on the community, the automotive aftermarket community and the network to kind of help me do some of that testing. So getting products in hands of people that know how to break stuff, and then putting them in the environments that they're going to be exposed to through the people that are kind of out there.
No, I think that's great. So let's move a little bit from prototyping to manufacturing. So when you move hardware to production, it kind of presents its own constraints. Nowadays, you hear about software and OTAs is a big thing, over-the-air updates. And what that allows on the software development side is you can actually release a product sooner. You can use your customers as beta testers. And then when you get feedback, you do an update and you send it back out and everything works, right? On the hardware side, it doesn't quite work like that. You have to physically change things. And things like warranties and recalls make that very expensive and cumbersome to account for after the fact. So when you're thinking about moving designs to production, what are some of the considerations you have to take to make sure that half your expense isn't going to be caught up in doing design updates after a final release?
Along with some of the prototyping opportunities that new technologies kind of enabled a lot of our companies to do, I think that there's some lower volume solutions out there. When we release a product, especially kind of on a new platform, that we might not feel, we're kind of 95% of the way there. Before we kind of go full speed into tooling into production, we'll kind of do, I hate to call it kind of a limited production, but a lower volume production, knowing that it might have some tweaks once it's kind of been put out there. And it's not that you have to do that for everything, but it's sometimes, again, there's some value to being kind of first to market. I think anybody would say that, but at the same time, if you were to wait for 100% solution to be kind of presented to you, you might be a lot longer to market there.
Yeah, I agree with everything that you said. And, we do pilot builds, like a limited production build, and we'll do some field testing with a limited number of customers. But a lot of it comes down to, what level of risk are you willing to take, and how well have you anticipated potential failure modes, and how well have you allowed for that in your design and in your tooling. If you have done some tooling, have you anticipated where your problems are going to be, and are they, have you designed it so that it'll be easier to make whatever changes are going to be necessary?
Yeah, I mean, I would agree with all of that. You all covered a lot of what I'd say from my experience. In hardware development, there's not a lot of shortcuts. And there's always risk involved, and it's really a question of trying to minimize that, trying to reduce the cost where you can, get the market as quickly as you can. I mean, we work with startups all the time. Everyone's trying to go fast all the time. And it's really a balance. I think things usually go wrong if you make one thing and it sort of works, and you immediately try to making a huge volume of those. That never works. But if you try to go really slow and check every box and have no risk, you're probably going to be too slow. So it's finding the right balance, but also having good processes, doing the right testing along the way, so you have confidence before you move to that next step.
I'll answer the question from a little bit of a different angle. I'll answer it from a compliance side. My colleague Dean sitting here in the back. So Dean actually oversees our emissions compliance center within SEMA Garage. So if you're wondering about what emissions compliance is, it's basically if you make an aftermarket product that affects air or fuel in the engine of a vehicle, and you're going to sell it in California, there's a rigorous tests that you must comply to, which are designed by the California Air Resources Board. So say you develop your prototype, fits, works, and you go to market, right? Because you want to be first to market. Well, if you don't go through the testing and the certification that you have to go through, if you're going to sell that product in California, get ready to recall that as soon as enforcement starts knocking on your door. So, and then once that enforcement hits your door, then you have to go back and possibly redesign your product, reinvest into it, go through the actual testing. So that's another way to look at it from a speed to market. Yes, speed to market is important, like Ian said, but it's also, you have to take it responsibly and understand if there are regulations or environmental needs that you have to fill, be sure to keep an eye on that and keep that top of mind within your product development cycle.
It's hard to ask for forgiveness on some of that stuff.
Can any of you share a time where either one of your products or somebody else's product you were working on, you realized the prototype wasn't manufacturable, and how you kind of navigated that process?
The first iteration of the fuel technology that I developed in college worked really good on the track and was just fine blending it in my parents' garage. But when it kind of came time to, hey, this might be a thing that I should do a little bit more seriously, I realized that it was basically unshippable. So there was one of those things where I bought a lot of raw materials, and like, I'm gonna go out and be an entrepreneur, and like right out of the gate struck out. And I had to kind of go back to the drawing board and do some reformulating. I know it's liquid, it's not quite hard parts, but you can still hold it in your hand. But that was definitely a tough one right out of the gate as a guy still living in his parents' basement.
I have just a couple of examples where it was manufacturable, but it wasn't ideal. And just, when you're designing products, I had designed a casting with a plastic lid that snapped into it, and I had designed the snap fits so that the tooling required slides. And so in a die casting, you can either have it open and close, or you can have other slides come in from the sides, and that can easily add 50 to 100% to your tooling cost and your piece cost. And just by tweaking the design, I was able to take a third of the cost out of the tooling by making it a simple open and close die. So it was manufacturable, but it was, it wasn't optimized. And I had another example prepared. I can't remember what it was. Another important consideration that is easy to forget about is the quality control. We've designed things that the quality department cannot measure. So therefore, it's not manufacturable in that sense. That sounds weird, just trust me.
No, so Damon, you kind of touched on this, but at Motivo, you've seen hundreds of prototypes try to move towards scaling and production. What do you think one of the most common mistakes are that people make in kind of going through that process and doing that transition?
That's a good question. It kind of related to the last question, actually, like prototypes that aren't manufacturable. Like, one of the big challenges there is picking the right process for where you're at. Like what I was thinking of is a lot of automotive stuff. Like if you're building a race car, or if you're building 10 or 100 specialty vehicles, like a steel space frame, it's like bent and welded by hand is a great manufacturing process. If you need to make 1,000 of those, it's a terrible manufacturing process. So whether or not something is manufacturable depends a lot on where your target is. And I think a challenge for a lot of people getting into this would be they have a big goal of, I want to sell 10,000 of these a year, so I need to use this manufacturing process to do that. But if you design around that and you're only at a point where you can sell 100 of these, or manufacture 100 of these, you're in big trouble. Because you can't pay for the tooling, you can't pay for the processing to get there. So you have to figure out what that kind of journey is to get from where you are to where you want to be. And that's tricky for enough people.
And then Kelly, with your experience in both product and manufacturing, where have you kind of seen the biggest gap between engineering optimism and production reality?
I wasn't sure how to answer this question, but one of the biggest challenges in my product development career has been to make sure that I'm collaborating with every other functional area in the company. Sales and marketing needs to be giving you really good targets for price and sales volume. And to your point, they need to give you the year 1, year 2, year 3, so that you can plan, up front. You have to know, does the warehouse have space to store all of the product? Does quality know are they going to be able to measure the product? And you have to work closely with sales and marketing on your launch plan. As you're getting closer, what do they need from you for the instruction sheets? And who's working on the packaging? Like, these are the kinds of things that can kill your launch date. If you're not coordinating with the entire company, one wrong move, one lack of communication missing somewhere can delay your launch by a month or 3 months. So to me, that was the gap that I always saw in my career, but that's preventable.
I think that's a perfect way to answer that question, because now I want to talk about the people around us as we're developing, because none of us are going to develop parts on our own. Even if you're just a one-person shop, the goal is to send something to production, which means you need some kind of team, even if it's outside. So let's talk about building resilient teams that build things. Hard tech problems often can take years, not just days, weeks, and months. And so what's kind of a practice each of you has gone through to keep your team motivated through that development process? We're self-motivated.
Yeah, the self. I think celebrate little wins. You kind of eat the whale one bite at a time. A lot of the projects that I think our company's taken on are, from kind of a 30,000-foot view, it's going to be huge. And how do you do it? And so with with my team, we kind of try to celebrate little wins and have little checkpoints and gates that we get through together. And failure is not a bad thing either. Obviously, we kind of look forward to failing early instead of failing at the last part. Celebrate when you can, because the wins don't always come all the time. So take a moment to enjoy it.
We never put all our eggs in one basket. We're, at the beginning of new product development, we will explore multiple designs concurrently and then pick the front runner. So, right off from the get-go that several of your designs are not going to make it. It's just part of product development, and there's always a lot of iterations, and it's just to me, it's a positive thing. It's just part of the process.
Yeah, I think I agree with all that. From my Formula SAE days, I think I'm very fortunate to have learned that getting car on the track, testing it and breaking it before the competition is the best thing you can do. It sucks to spend all this time engineering something and building something, and you get it out and a minute later it's broken. But you learn something, and I really try with our engineering team to kind of instill that same thing of it's not bad to break things, it's not bad to fail. If you do it at our shop, you can fix it much better than if you do it when it's in the customer's hands.
Yeah, I would definitely agree with that. Within my team, I give them the power to make their own decisions in certain projects, take risks, but also take ownership as well. And then from a higher level within my team, overseeing those operations, we like to use the term, fail fast if you're going to take a risk, and learn. Definitely, don't stay stagnant. Always look at new ways to improve and be more efficient. And with that comes risks. But it's all about taking ownership and accountability.
I just wanted to add that if nobody's making mistakes and nobody's failing, then you're not really innovating.
No, that's a great point. And each of you talked more or less about lessons learned from that. And so what's kind of the ways you can pull some of those positives and lessons learned when you less scrapping ideas and starting to take shape?
Urban helps. I mean, like you said, if you're not failing, that's actually awesome. I'm gonna steal that when I go home. If you're not failing, you're probably not innovating. But sometimes you miss the mark, and it's a tough pill to swallow. But I think it's okay, because I think you do. I was always told that you learn more from losing than winning. So if you can take some learning aspects out of, even if it's completely scrapping an idea, I'm probably pretty sure that you're walking away with something that's valuable towards the next thing that you're going to be working on. I mean, I don't think any company in this room or within SEMA or SAE, everything hinges on one thing. So if you got to scrap it, just make sure to learn from it and keep moving forward.
Yeah, everything you said, we've done a formalized lessons learned event, and it's a non-confrontational event. It's let's look at it, let's break it down, and it's not a blaming event. It's let's learn from this, and it's just you document it all for future people to learn from.
Yeah, I would say through working at the SEMA garage, I've had the opportunity to deal with hundreds, if not thousands at this point in my career, of aftermarket companies who have been startups, and sometimes, the engineer is also the owner, it's also the business seeker. But, they've gone through, scratch paper, design to actual CAD design through our services, and developing prototypes and some testing. And sometimes it just doesn't work, right? Or they're too late to market, and that's okay. You take a step back and you go back and you analyze, and and reinvent your product or expand your product lineup. So yeah, I've had the chance to see a lot of that, and I mean, they didn't go bankrupt. They're still well and alive, and that's just part of their nature.
Also, the only thing I think that's worse than completely scrapping a product and being sad about all the time and money that you've invested in it is pushing that product to market. Because I'm sure we can all think of a product that was like, that should have been left on the cutting room floor. Like, ooh, that's, but, that's, that would be my biggest fear is, kind of not making that hard choice and then continuing to pay for it down the road.
Yeah, I think when we did this talk at SEMA, one of the panelists who couldn't make it tonight was Kevin DeMoa. He's the founder and CEO of Glide. And he said something really powerful that stuck with me ever since. And he talked about paying rent for your space on the earth. And part of that was like going through the process, failing at it, but then learning from those failures and making sure to spread it to the people around you who may be going through a similar thing. And I thought that was a really great way to put it towards even hardware-based development. So with that, if someone in the audience is thinking about starting a new hardware product, whether that's a Formula SAE car or an aftermarket car company, what's kind of one piece of advice you would give them?
I work with a lot of clients at Motivo coming in with ideas that start out simple. And I think maybe the biggest one that defines those that are more successful is they go out and talk to potential customers, figure out what people actually want. The most challenging clients are the ones that think they have an amazing idea, it's in their head, and they haven't vetted it with anyone else. If you're trying to start a business, you have to have customers. You have to figure out what your customers want. That's number one.
That sort of leads into where I was going to come from is you have to have a rigorous product definition, and it starts with sales and marketing. What are all the features and characteristics that are required? What are the must-haves? What are the wants? What's the volume? What's the target price? What are the regulatory requirements? What environment does it need to function in? All those, you have to be as rigorous as possible. So you have to be comfortable working in gray areas. You're not always going to have all of that information. And sometimes it's hard to pin sales and marketing down. And what works for me is I'll throw out an opening number. What's the target cost? Oh, we don't know. Well, is it $100? No. If you start giving them numbers, it makes it easier for them to help you understand what your targets are, and because you can't work in a vacuum. And as rigorous as you can, as detailed as you can, get that product definition spelled out, and just plan ahead and go from there.
The not operating in an echo chamber, you like get outside and ask people, because you need somebody to tell you your baby's ugly. If it's the same people telling you that it's the greatest thing ever, it's like, man, this could be weird. I mean, for guys that are, a part of these teams right now, I mean, that's where a lot of those cool ideas come from is, hanging out with your buddies and working on stuff and solving a problem. And, my biggest thing is if you're going to go out there and take a crack at it, be confident that you're solving a problem that, other people are having. But be willing to hear tough love and hard information because if you're not willing to hear it now, it's going to hurt a lot longer down the road.
Yeah, I would definitely say if you can solve a problem or make something more efficient, that's the key. I mean, the amount of products or technology that I've seen, in past years when I've gone to CES, it's just like, did you think about the application for this product? And I don't think that really resonates with a lot of folks in some cases. So it's cool, it's flashy, but is there a true application? And are you going to have, somebody mentioned this, but are you going to have actual a buyer? Is there a market for this product? And if there's not, then what did you just spend all of this capital money on?
Engineers love over engineering.
Oh, yeah.
Yeah.
Let engineers engineer. Well, I guarantee some of you out there can have way better questions than I've been able to come up with. So why don't we kind of open it up to the audience and see if there's any questions for this group?
Can you repeat the last part of that question one more time?
Like, say you're a big aftermarket company done superchargers.
Yeah.
How do you go about testing them without blowing up the ground?
What does the waiver look like that you have to sign before you do your testing?
I won't get into details. I mean, there have been cases like that. So I'll kind of just give you a peek behind how we run our business in the SEMA garage when it comes down to testing for emissions compliance. And the experts are literally about 10 feet to your back right. So if you're an aftermarket company, you develop this supercharger, right? And then you have to seek out a brand new Corvette, a C8. It is primarily on you to find that owner of that vehicle. And it's primarily on you to set the liability with the owner of said vehicle. So there's risk in that, without a doubt. There's scenarios where engines have blown up, cars have caught on fire, and that's just that is part of R&D. Unfortunately, I don't recommend that. But there is a risk to that. But then that also has to come with your communication with the vehicle owner or the company where you hired the vehicle from. So the way that we handle that is there's very clear language of when a member brings in a product into our facility and where that vehicle is coming from. There's a lot of liability and legal documentation that goes behind that. But great question, though.
Yeah, so when it comes to determining the durability of your products and deciding like the warranty, whether it's going to be like, 2-year or 5-year or whatever, right? And that product, there's either it doesn't really exist or there's not much data. What do you use to determine what your durability testing is going to look like? How many cycles you put the product through and things like that before you push it to market?
That's a whole field of engineering called reliability engineering is how I've done it. And you don't establish a number of cycles, you test to failure. If you test 1,000 cycles and 10 parts pass, all you've learned is that 10 parts lasted 1,000 cycles. If you test 10 parts to failure, you get an astronomically more information. And there's a Weibull plot, and when I took that training 20 years ago, you do your Weibull plot and you extrapolate and you figure out what your life expectancy is, and you test. The other thing with reliability engineering is you don't test one environment at a time because you can get interactions between the environments. So you try to test in multiple environments at a time, temperature and humidity, for example, and test to failure is key.
I'll kind of answer a little bit. You touched on like warranty. I'll approach it kind of from a customer experience standpoint. I think I'll let sometimes cost dictate, if something's going to have a limited lifetime or a lifetime warranty. From a marketing and sales perspective to the customer, to show them that, we have a lot of confidence in our product, obviously testing to failure. We definitely don't want to send something out there that's going to break the next day, but backing up our product and saying that if it's not a supercharger or something that's crazy expensive, just saying, hey, we'll give you a lifetime warranty because we want to replace it, and for you to have a good experience with our company as a whole, and continue to use our products.
Yeah.
Just thinking from a design standpoint, when you're managing budget and trying to produce the best product you can, do you approach with budget in mind, or do you try and solve the problem first and then cut on resources or make the product cheaper after you quote unquote solve this problem?
Yeah, I think that's a tricky one. There are almost always budget and schedule constraints, and I don't know, there's a lot of different ways to look at engineering. I would look at engineering as, how do I develop a product that meets all the requirements in the shortest time at the lowest budget I possibly can. On one thing I often see with a lot of newer engineers is, oh, there's a better way to do this, or I could make this stronger, or any number of things to do more engineering to make a better product. But many times, if you have met the requirements, if you're exceeding them, that is actually kind of a failure in terms of engineering. So kind of optimizing around that is what I would.
There's a reason why SAE competitions also have business presentations in there. It gets you a little bit of a peek behind what you'll experience in the real world. Yeah, you're not always just going to be stuck in the design part of it. You got to consider all of the other aspects of it.
I think that's one of the biggest values of Formula and Baja with SAE is that with the business aspect of it, you guys kind of become a more well-rounded engineer because you're keeping that in mind when you're developing and designing things. Because engineering in a vacuum without a budget, you're going to have some pretty crazy stuff that's probably not going to be anywhere near possible for production or manufacturing or anything else like that. So, having that thing, that bird on your shoulder saying this is going to be way too expensive, don't do this, is good to develop. And I think a lot of you guys get the opportunity to do that because I don't think I've never met a Formula or a Baja team that has an unlimited budget when they're building their cars. So it's a great skill to develop as you're getting your degree.
Yeah, I was gonna ask about testing. So I think on the panel, there's a lot of cases where you have a formalized test plan, FMEAs or stuff like that. How do you go about planning testing when you don't have a standardized process?
So the questions about like getting formalized, when you don't have formalized testing, kind of how do you set up your test procedures if maybe you haven't done it before, or it's kind of a new type of testing?
I always start with the design FMEA, the failure modes, effects, and analysis. Just listing out all the potential failure modes, and that's a good starting point. And then you can target your tests to specific aspects of your design and specific phases of the design. And you can have really quick and dirty tests. They don't have to be elaborate.
Yeah, I'll add to it. One of the parts where I see where there's a challenge in testing in our industry is, and I'll pick on the advanced driver assist systems here. It's not just developing the aftermarket suspension, right? So once you get through all that, you check it out, it goes to market, but then you got to think about the application of this. So now you lift this F-150 or F-250, then you got to think about what is now the repercussion of lifting that vehicle in regards to the vehicle dynamics of that vehicle, right? Is your product now taking the vehicle out of spec when it comes down to rollover or the performance of those electronics? Like, you got to think about not just the development of the product itself, but then also the application. And that's where it gets a little bit challenging there, because then you got to do some research as far as where you're selling this product, what is the application, what are the federal or state requirements that I am now required to meet.
Yeah, and I can tell you at Motivo, we pretty much only do like new developments and prototypes. How our test plans usually come about is we'll look at what the original requirements were. So define the requirements at the beginning when we get into system architecture phase, and then we're going back to those requirements. And so our test procedure is to validate that we've met those requirements more or less. And so while there isn't structured testing that we can just follow on a lot of our products, that's kind of what we do to force that back into the box, is go back to what were we actually trying to accomplish here? Did we accomplish it? Yes or no? How do we prove we've accomplished it? That's what a lot of our testing procedure looks like. Go ahead.
You maintain all the assurance if you start testing, like for example, like a manufacturer.
So I think that was, how do you kind of maintain quality assurance when manufacturing processes change? Yeah.
That's a great question. And every industry is different, but in the automotive industry, you're not allowed to change a process without validating it. It's an OEM requirement. You're not allowed to move a steel stamping press 1 inch without requalifying all of your parts. So it's just a customer requirement.
Yeah, I guess Damon or I could take that from the other perspective where we're not in like the rigor of an OEM. It's actually simple in the sense of communication. Like a lot of times we'll have to even change out a component, right? Of, hey, the supply chain is, the lead time on this component is too long. We're gonna have to switch it on your prototype. Communicating with the client and then making sure we're still aligned with what that, how we're going to QC that part when it comes through, even though it's a slightly different part. The communication part is there. I'd say a lot of the larger industries, automotive, OEM, aerospace, have the rigor they have because of poor communication, and it's to actually circumvent that. Us being so small and moving so fast, we have to rely on that communication. Any other
Yeah, so during the session on prototyping, I think Ian mentioned 3D printing. I'm interested in the entails, I think there's another school of thought that might call that additive manufacturing. Is 3D printing still a prototyping tool, or is it ready for prime time start manufacturing?
So the question is, do we think 3D printing is ready for the main stage of being actual manufacturing process, or still considered part of prototyping and additive?
I have too many parts of my car that are 3D printed. It's good. I mean, the technology is wild, right? And I think the filaments and the stuff that we're having access to and being able to print. I mean, where we're seeing strength and durability that is pretty incredible. And for some companies, it might be the only option. As far as trying to, bring a product to market. But I'm all for it becoming, coming more to the main stage.
I don't know if it's there yet. I think it's expensive and it's, it might be good for low volume, but I'm not sure if it's entirely there yet. I know they're coming out with new materials all the time. And, I ran a machine shop and we weren't in competition with the metal additive manufacturing because it's really expensive. The competitive advantage that I saw in metals was they could manufacture parts that could not be machined. They could have interior cavities and things like that. So that was the competitive advantage. So we weren't really in competition with them. They were sort of a separate niche market for us.
Yeah, there's you guys are familiar with the vehicle from General Motors called the Celestique. Just a small batch production. There's a limited amount of it, but that vehicle has a lot of metal and plastic 3D printed parts in its production. But then it's also in the supercar industry too, right? If you look at like some of the hybrid cars, actually, like if you look up C Singer, they're actually local to here. Look at the engineering behind that. Like that's you hit like. In SolidWorks, you went to like design optimize this, and it looks like a wishbone, and it's amazing, and it's metal 3D printed, but they're only making a handful of them. So you're not going to do that to like your F-250, right? Like it's not to that level.
Yeah, and I just add the expensive is kind of the key there. Like metal additive is in production in aerospace and space, where the mass savings is worth it. It's way, way far away from being in production in like high volume automotive. So the cost of the mass just is not worth the money.
Just to be clear, Dina, I want it to be there. But yeah, they're right.
All right, maybe one more question. Go ahead.
When it comes to bringing a product to the masses, I know you guys have to set up your timeline schedule and really there's space for guys for prototyping, pre-production, production. For your criteria of when finding a good number of each phase, is it continuously evolving or like you meet certain specifications, or you go through prototyping and suddenly, maybe you need to do this for pre-production, or go through this, or is it really just like different bits and sits? Well, what's the gauge there? How do you guys like mitigate constantly bringing in more and more activity?
Yeah, so the question is, how do you kind of define the criteria as you go through the different milestones of development, but how do you not add too much to slow yourself down? Is that kind of the gist?
Yeah, I mean, one answer is it varies on what you're building. Like you're building a rocket that goes to space, you're building a car, you're building a simple product that the risk isn't that high. One thing we try to do a lot of is look at all the different parts and systems that are being designed early on, and like, what is the risk of each of those? What is the lead time? Like, how long is it going to take? How much time do we have to change it? Like Michael said earlier, software often you can keep iterating until the last minute and like make a software rev very late and ship it. You might have some high volume manufacturing part where you have to decide a year in advance of production what the design is going to be. And all those things are going to have to overlap on the schedule to make smart decisions about when you need to make those decisions.
I think, Damon, you said earlier something that kind of answers it. It's finding that balance. You know, there's risk, you know, coming to market in time, you know, cost. There's a lot of things, just finding kind of that balance, and it does vary, but the balance is something that's determined within the team and, you know, what's available to you, but it's, you know, it can be tough to find the balance, but I think that's what we're all looking for.
And as you go to market too, as you know, as time progresses, you know, there's always, you got to think about this too. From, I know we're all here because we all know SAE as a student program, but you got to think about SAE as the international standards organization too. So those folks, and I sit in a couple of SAE committees that develop standards for today's market and in the future. So those standards then get adopted by regulation, and then that gets trickled down to what does your product have to meet in order before it goes to market.
Well, I want to thank everybody for coming out tonight and kind of listening to some of the insights, greatly appreciated. Of course, I want to thank the panelists for sharing their wisdom and their experiences and their failures and how they learn from it. Because this is something everybody in this room more or less will have to deal with if you're coming to an event like this. And so getting those experiences from the people around you, I think, is really powerful. So thank you so much for providing that insight.